Hello everyone. Thank you for joining me at Conf42 DevSecOps 2025. We will discuss about Semgrep and open source static analysis. My name is Safir. I'm an SRE for more than 20 years of experience, and I have worked in reliability, infrastructure, and platform engineering. I'm another and a speaker, and I'm currently working at the principal engineer's mode. So, what is SAST? So, it is static application security testing, also known as static analysis. What it does is discover vulnerabilities in your source code before it reaches production. SAST can scan an application before the code is compiled or built. It is also known as white box testing because the tool has access to the original source code. So, what is the advantage of using SAST? See, manual security reviews of every code change is impossible. Nobody's can scale at the volume your code is generated. Right? So, shifting security left is the only way. And since SAST has access to your source code, it can do 100% code coverage for all security vulnerabilities. It can also scale across large code bases and can run for every change, every commit that you make. So it can also identify certain well-known vulnerabilities like SQL injection, secret key exposure, buffer overflows, and things like that. But it is not limited to that. Like large number of vulnerabilities and attacks so they can bubble. So the initial SaaS tools, otherwise known as first generation SaaS tools, had its own issues. They were clumsy, their scans took hours, and the setup was complex, and the result in itself was not very trustable. And many developers, because of this, had security fatigue and felt that the tools, SaaS kind of tools are useless. Now, the difference here is that in second generation SaaS tools, it also has issues. It also brought some improvements, but some of the issues still are higher number of false positives. It's also difficult for SaaS to detect advanced security issues like authentication, access control, and authorization, and things like that. It cannot detect weak cryptographies or any other kind of security issues. It also cannot find out issues with the configurations because it only looks at the source code. So, how does SaaS work? So, the source code is broken down into tokens, keywords, identifiers, operators, and one is in the program. Then these tokens are analyzed according to the grammar rules of the language to create a hierarchical structure of code. Typically, this is abstract syntax tree. And this step determines how the program executes. And in the case of control flow analysis, it determines like how the control from the program flows from one part of the code to another. And then there is data flow analysis, which tracks how data is manipulated and traveling through the code. And once the code structure and the flows are identified, the predefined rules or patterns are applied to this structure, and it can detect common coding errors, instead practices, or indicators of potential vulnerabilities. And that's the way SAST operates. Now, we talked about ASTs briefly in the previous slide. So, what is an AST? AST is abstract syntax tree, which is a tree-shaped representation of your code that captures its structure and need, not its raw text or formatting. You can think of it like how a compiler or interpreter understands your code internally. Now, why is it code abstract? It is because it ignores details that doesn't matter for the meaning or the purpose of the code. No comments, no white space, no exact formatting or verification, things like that. As you can see on the all of this, essentially, if you look at from a pure text or pattern perspective, these four print hello world statements are totally different. But when an AST is generated out of these four statements, they are all going to this. That is the beauty of using ASTs. It gives you a deterministic program-aware structure. Now, let's look at a similar example of how a Python hello world program is converted into an AST. So Python provides an AST library which takes source code as an input and then returns an AST. And as you can see at the bottom output, the AST provides a tree-like structure for the code. So to make the concept a little bit more clear, let us look at the graphical representation of the same. As you can see, the code only has one expression, and the function name and the arguments are split as tokens and are under the same node within the tree. So let's look at a slightly different example to clear the concept here. So here we are using a variable assignment and then printing the variable rather than directly using a scalar or a string print. This creates two subtricks, one for the assignment and another for the function. And if you have a large number of lines, or you can see how this will expand into a huge tree. Right. So let's talk about Semgrep now. So Semgrep basically is a tool and a platform. It's available at semgrep.dev. The core of the Semgrep is an open source engine for vulnerability evaluation, and that is called C or Community Edition. Now, so it also has a Semgrep Pro and a commercial SaaS platform, which adds additional features, reporting, center tooling, etc. So, what is the name Semgrep mean? Semgrep essentially is semantic grep. Semantic essentially means that Semgrep as a tool understands your programming language semantic and then uses grep, or not exactly grep, but grep means patterns, grep-like patterns that you can use, apply it on your code basically. So the commercial platform also, while we are covering Semgrep CE here, the commercial platform in itself, not just the SaaS, it can also do software composition, analysis, supply chain security, etc. So how does Semgrep work exactly? So Semgrep doesn't need compiled artifacts. It works directly on the source. So it will code into an AST, and then there are rules which are patterns that match against this AST to detect insert code or buggy code shares. The thing with Semgrep is that it is not just code, but the rules are also converted into ASTs so that the match becomes much more deterministic and easy. So these rules essentially are YAML structured documents that can be either stored locally or centrally in a registry. And you can also write your own rules and run them against your code locally. And out of the scan or the Semgrep scan of your code, it can either be a simple text output that you would see in a regular CLI, or you can convert them into JSON or a security suite format called SARI, which helps you in integrating this with CS systems or other security tools for the code. So the core of Semgrep is the patterns of the rules, right? So the Semgrep patterns looks pretty much like a real code. You write a snippet with the placeholders for the parts that you want to do, or apply specific rules, things like that, right? So let's say, for example, you want to match a Python function code that directly uses the library called request.get. You can just request.get as a pure statement. But let's say you want to use the within request.get, you are passing a URL, and you want parameters at URL and do some checks on that URL. Then you can you can create some, or there is something called meta variables within Semgrep, which is essentially parameterizing and creating a variable out of that meta. And then you can apply rules on that way. Now, in addition to that, a single rule has multiple things. It also has metadata like messages, severity, language, etc. And the good thing about the pattern rules is that since these patterns are order-like, developers can read, review, and iterate on rules without needing to learn complex CSL. So what is the structure of a specific rule? The first thing is a unique rule ID. It just has to be a string, could be in any format. Here, see, here is something that is structured like a company, then type of vulnerability. But in reality, it can be anything. So the pattern is what defines your actual match criteria, the code snippets that you have to scan. And message is what a developer will find when you scan against a vulnerability and it takes a vulnerability. The message is sent as an output. And there is a variable that pins a rule to one or more specific languages, which makes it easy to filter out rules from a large number of rules for multiple languages. And metadata for a message or a rule can store CV, links, documentation, internal wiki pages if you're writing a rule, things like that. Right? So this overall structure allows you to build an internal rule set that can reflect your organization's coding standards, security practices, and also educate your developers by using the metadata effectively into reporting into specific secure code guidelines, documentations, etc. So let's look at hello world program in Semgrep. So our code here in question is a simple print hello. That's a simple Python one-liner. And the rule is essentially going to match it exactly for print hello, because we are looking for the pattern print hello in any program, any Python program. And here we will get an exact match because the rule and the content of the file, program remains the same. Now we'll just run that rule using Semgrep CLI against the rule code. Now what you're seeing here is CLI and all this stuff. beautification output, but it found one issue. If you see here, it outputs what is the file on which it found the issue. It outputs the rule. It also does output your message. What was the exact error about? So this is for like your metadata, messages and comes in picture and use the developer context, right? And it also, finally, it also outputs line number of the program and the program step that it quotes. All right. Now that we have found our hello world program, let's move on. So we talked about pattern. Right? Pattern is core of your rules, Semgrep rules. So there are different ways to indicate and define your patterns. So if you just give pattern in the YAML file, it is a single pattern that it is indicated. You can have multiple patterns by stacking them as in a using pattern either. You could have a list of patterns and any of them could be matched. Then you can have patterns, which essentially says you can have multiple patterns, but all of them are considered. It's like an AND. And then there is pattern regex, which allows you to match against, again, it is like pattern, a single pattern, but it matches against a regex instead of a pure test, right? And then there are nestable pattern operators. So let's say you define a top level element for pattern or pattern A, which is AND or, and then you can have one or more of these sub pattern operators, which put a pattern inside, which says it will look inside, the code, or pattern node is a negation. Pattern node inside, if this code is not inside the particular block, or it doesn't match the specific regex, things like that. Then, of course, there is meta variables that you already talked about. Meta variable is essentially nothing but a placeholder for some part of your code, which you want to process later in the pattern match, right? Now, for that meta variable, let's say you are, as I mentioned earlier, right? Python request.get is basically for retrieve URL. So let's say you are passing the URL and you want to variabilize that URL, you can use meta variable. And then in the next line, you can probably use like meta variable pattern to look up for the pattern within that URL. You can do a comparison, you can run regex, anything that you want from more fine grade control. So these are a few examples of patterns. As I said, pattern essentially is you could have a bunch of patterns in there. The first pattern, if you see, patterns defines, you can have one or more patterns. So you can list additional patterns in here. And as you can see, this is a multi-line pattern, not a single line pattern. Pattern 2 is also a multi-line pattern, but it's a negation of pattern, which says pattern stop. And the third one is basically a pattern either, which means this is actually a pattern for SQL injection, finding SQL injection, and there are 3 patterns. If any of them matches, the rule will say, rule will alert that there's an SQL injection. So structural matches versus data flow. Structural rules in Semgrep are basically a rule that matches snapshot of a code shape in one place. Then there is data flow rules. Consider how your data moves from one place to another within your process. And then there is chain analysis, which tracks untrusted input flowing to your dangerous APIs. The Semgrep community edition essentially only looks at role-based engine and a single file code. Pro engine, on the other hand, gives you advanced inner file scanning, train support, etc. Now, I'm talking about some registry and community rules. Registry is essentially 3,000 plus open source rules available in Semgrep base. So if you are just starting off, you can just start by running your code against Semgrep registry with all the default rules that are available by the community. So most of the rules covers like industry best practice, like OWASP, Prop 10, common use, and framework specific issues, right? And Semgrep is offers a CLI, and the config equal to auto option allows you to just talk to central registry and pick whatever is applicable or relevant to your code. You don't have to do anything specifically. It will just automatically determine what is a local language, and based on that, it will go to the registry and put the local language and the framework specific rules from the registry. Now, you can always fork and tweak some of these rules, make it your own, or copy it locally. And this helps you in building like rules from existing. You don't have to start off from the scratch. Rather, you can start from the open source rules, then make it your own. Collaborate locally, keep the rules locally, and develop as your code and your organization needs you. Now, if you're installing Semgrep, it's of course CLI, and there are multiple options like Docker, depending on where you want to install this CLI. And as I mentioned, auto rule configuration is the easiest one way to get started off. But of course, you can point your configuration to local or to multiple locations, and it will accumulate rules from all these locations and run it against your. So result, of course, is by default you will see it on the console as we saw earlier. but you can also convert the view into JSON format or serif format so that it can be integrated with dashboards, GitHub code scanning, or any other security tool. So now let's look at where all we can integrate. Also, set up the data comfort Semgrep, where all we can integrate Semgrep, right, in the SDLC. So the earliest you can integrate any tooling in the SDLC is in the IDEs when the software is actually getting developed. Semgrep has plugins for most popular IDEs. And this means that you are shifting it to the at most left of the security. And you can catch incorporators before they even committed into the local row. Right. And the developers can immediately get hints and fix patterns they might otherwise repeat somewhere else. And this also makes it easy. Change Semgrep stands from a gatekeeper or an entry point to a teaching tool that continuously educates developers about security issues. Now, the next option is, of course, we are moving towards the right now. We were at the extreme left, the IDE plugins. Now we are looking at pre-commit hooks. So pre-commit hooks also creates a natural low friction checkpoint. It's a checkpoint, it has a bit of friction, but it is still low friction because when you make the commit itself, you use Semgrep to scan the changes that you have committed. And that makes it easy to integrate into your pre-commit hooks because only the changes are looked into. And when Semgrep finds something critical, it can block the commit with one or more clear messages, right? And that helps in catching before this is committed. CI/CD integration, and that is you can have just a pre-commit hook, you can have automatic scans for every committed, right? And again, on all these steps, the rules might change. In the IDE, the developer might have more specific rules that he or she catches. In the probably there's the team, the repo owners are maintaining a set of tools that they only know about or very specific to their code base. And CI/CD, where you can implement community roles or with specific roles that your infrastructure or DevOps teams implements. So that is how the scanning process. Right. So when you are adopting it, initially you should start with some soft fails, right? Rather than first just give a warning, put a warning in, unless it's a very critical security issue, just put a warning in the logs CI and move on with it. Also, SARI for JSON based output, put it into GitHub or some other reporting tool that supports SARI for. If this is an example of GitHub actions of file, if you want to integrate them to your CA or CD process, CA process, this is a sample that you can use. You can also use Semgrep in code review or VRR. What it could do is can make security review a part of your review culture, right? And instead of reviewers manually looking at common patterns, rules can automatically do that and also comment on the PR. And over a period of teams can find, okay, what are the issues? Then add more rules in the base and the private knowledge get translated from people's minds Semgrep rules. Noise, right? So, of course, as I mentioned earlier, SAST, the biggest problem for SAST is or the noise, we can call it. So, to avoid that from early on, and to avoid hindering of adoption, because once developers find that if even too much noise, they don't look at the tool for their results, right? So, to avoid that, start with baseline scan and focus on some of the new issues. Setup gives you options like exclude during runtime, Semgrep ignore as a file within the repo, so that you can ignore certain patterns or even certain parts of the code base. All right. And slowly iterate on the rules and the patterns and combinations to reduce force codes. Realistically, on a daily flow, a developer can implement the feature, see some warnings in the IDE, fix, and then run the git commit and pre-commit process, which means everything is very good. And then in CI stage, some kind of check for all the full changes and comment on any issues. Reviews can happen, and during the review, engineers can review and add additional suggestions. They can add additional values to the rules, things like that. And over a period of time, there will be fewer issues that is getting through your code because all your baseline things, security issues are taken care of or flagged by Semgrep. Gives a much faster feedback. So that's quite useful in terms of getting your security left. So when you are adopting Semgrep, don't turn on every rule at once. It adds fatigue and for the developer, right? But start small. If you suppose limit a rule set, focus on the developer's experience first. because they need to get used to running Semgrep tools locally. And then only you should know more rules, more repos. And even there is success stories, like, in this particular application, Semgrep code, so what enumerable is, which encourages others to start adopting Semgrep, right? And you can, of course, work with security engineers side by side for into the rules. And also, you can join local conventions, local rules, and add additional rules, do things like that, so that you have a much better security culture. And let's look at a very quick demo and see a few rules and code. So as you can see here, we are looking at 3 types of rules here. So you have already seen our Hello World program. So other than that, we have 3 more set of rules and corresponding programs here. So let us start with the first one, which is SQL injection. So let us just look at the file first. As you can see, this is the rule for SQL injection. What we'll see here is 3 patterns. It's an either pattern, any of this pattern matches, it's an SQL injection. So if you see here, if you remember Python, there are cursors that you can use to execute SQL queries. And the first argument is, of course, the query. So now this pattern essentially says any pattern plus you are concatenating a variable, then that is an insecure pattern. Second one, you use an F string and then use variable within that. That's also an insecure pattern. Or you could use the percentages for implementing variables within the query. That's there also. If you are using a variable and a text together, then that is again another chance of SQL injection. And of course, you can add metadata about what kind of vulnerability this is, what kind of category this is, what technology or language it supports. Languages given here, technology is more like metadata, right? And as you can see, the ID here is again something unique, right? And you can choose what this ID should be, right? And again, security is you have a very verbose message that there's an SQL injection and how you fix that. Let us look at the sample program. The sample program is quite simple. It has 2 functions, and both of them executes one SQL queries. As you can see, in the first one, there's a pattern where the variable is concatenated, the user ID variable, and the second one, it uses an F string, but again, it inserts a variable here. So both are insecure patterns. Let us this pattern against the file and see what happens. Cool. So as we expected, it found 2 issues. As you can see, the file scanned is this one. The rule ID is this one. And as you can see, there is 2 issues that it code, or it rather tells you, I think this is possibly skill injection, and these are the 2 patterns. Out of the 3 patterns we gave, 2 of them were detected here. Let's move on and look at the next type of program, which is input validation. So let us say, in your organization, you want to implement a standard function, which will do or validate all sort of inputs. Now you have done the function. It can be included as a library and a function in your code, but we need to check whether the developers are actually using it during a program. Right? Now, to do that, we again define, there's an ID and other whole things. And then you have a pattern, which defines, it's a multi-line function, which defines a function. Then there's an argument passed to the body, right? So that is it. And this is the next one. Valid. If you see what is the difference here, both are same function definition, but in the first one, it could be that could be anything. In the second one, there is actually a function called validate input. And this is the right way to do it, because validate input is a function that you gave to your organization so that everybody in the company uses this validate input. Now let us look at that. So there are 2 functions here. The first function just processed the input as it is. And the second one actually validates the input first and then only process that. This again from this one. Again, we found 1 issue because the second one actually, the second part of the code actually used the validate input function. The first one did it. So that was code. And as you can see, this is a multi-line pattern, and it found all the lines that matches the pattern. Now let us look at a third and the final pattern. This is quite common nowadays. People commit their AWS credentials, which includes access key and a private secret key into them. But let us look at the rule first. It's a little lengthier and it uses a specific pattern type. So if you see the pattern here, right? Essentially, most of the time, if you are using access key or a secret key, it will be in a variable assignment format, and that is exactly what it is, a simple variable assignment. Whereas there's a var, and then there's a value, right? Now, here we are making use of meta variables because we define the $var and $value, right? Now you can apply pattern in any of these things, meta variables. So here we are using meta variable regex within the pattern. And what it says is meta variable to be used where evaluated is value, dollar value, and the regex is this one. So this is a common pattern for this one. What is it? This is a common pattern for access keys, not secret keys, for access keys. All right. So it is going to have first specified bunch of defined patterns, but there will be 4 characters, and then there will be additional 16 characters altogether, making it a 20 character ID. And you look at the second one, we are looking at the secret, AWS secret, right? Now in here, it is pretty much like a base 64. The secret key is pretty much looking like a base 64 encoded line. You have alphanumeric characters plus slash plus and then equal to, and the total size of the key is 40 characters. And let us look at the program that used it. This is a quite simple program. There are 2 functions. One of them just have dummy credentials here, whereas this function here has a core AWS access key and secret key embedded in the code. Right. So let's see what happens when you run Semgrep against this. Cool. It did 2 code finds. The first one is finding the secret access key ID, and the second one finds the secret key ID. That brings us to the end of our demo. I hope you got an idea about what Semgrep is, how Semgrep can be used, and I would urge you to not start using Semgrep or any other SaaS tool in your SDLC work. Thank you.